What's up, everybody? Mystery Lane back with another video. This time we're in Tinkercad and we're playing with LEDs again. And I've got my circuit actually hidden here because I don't want you to see how I've got it hooked up, because I want you to try to figure it out yourself. Okay? I wouldn't recommend running wires like this though. Definitely you want to put these LEDs on your breadboard when you're making your circuit. And let's shut off the factory sound like air conditioner in the background here. Let's get that shut down so that's not going to take up so much sound in this video. There we go. Isn't that better on the ears? Okay, here we go. So I've got my LEDs set up here, and this is actually a very short program to control these LEDs blinking back and forth like so. And I'm going to show you how to use arrays to control your LEDs. And yeah, you should be able to get a very similar program here like this to control your LEDs instead of having to do separate individual digital write lines for every single pin number and making variables for every single pin number. That can be really annoying if you want to control a lot of blinking lights. So here we go. So I've got my 5 LEDs here, and I'll go ahead and show you the Arduino board. Let's look at the board. So I'm using pins 3, 5, 7, 9, and 11 for my LED pins. But what I want to do is, instead of having variables like before, so before I would have done like int LED 1 equals 3, int LED 2 equals 5. Instead of doing all that nonsense and having 5 lines of code every time I want to control something, I'm instead going to do an array. Remember, an array lets us store lots of information all in one similar kind of variable structure, I guess you'd call it. And each of those compartments in our structure has an address. So we're going to make an array. We're going to call it int LED pin. And we need the empty brackets to tell the computer that it's an array. And we are initializing this array with values. So we're not making an empty array, so we don't need to do the new and then type the type again. So we're going to actually tell it what numbers we're using, and this is where we're going to put our LED pin numbers. So we're going in order here: 3, 5, 7, 9, and 11. So that is our array. So paying careful attention to this now. This is where it gets a little confusing. Okay, so I'm going to come down here in the comments and make a little comment line. So the index numbers, right? That's the important thing to keep track of here for this array to understand the math. So even though these are the things that are stored inside the array, the index numbers for these numbers are 0, 1, 2, 3, and 4. So whenever the computer is using these numbers when addressing the array, they are mapped to these numbers in order that are stored in the array. So index 0 maps to 3. So that's if I do anything with, if I wanted to set up the array set up my pins the old-fashioned way, I would have to go pin mode, LED pin, and then I would need to put 0, and that's output. And now that would set pin 3 to an output, because that's address 0, which stores the number 3. And I could just kind of go ahead and copy all of this like so. I can do it 5 times, and I would just change. This would be index 1, this is 2, this is 3, and this is index 4. So in these lines of code, I am setting up each of my LED pins to be an output. Now, there's a nice neat pattern here mathematically, and that's the advantage to using an array, because I don't actually need 5 lines of code. Okay, I can do this exact same work with a for loop. Okay, so I'm gonna put the for loop here, and then I'm gonna comment out all the previous lines of code. Okay, because we won't need them when I have the for loop in here. But then we'll be able to kind of uncomment and recomment to just kind of show you that it does the exact same thing. All right, so our for loop, we're going to say for, and I need to declare my counter variable. So int I gets 0. We're starting at 0, semicolon, while I is less than 5, because as soon as I get to 5, we know that 5 is not going to work. That's an index array index out of bounds error. And every time I go through, I'm going to increment I by 1, so I can say I gets I plus 1, Or the fancy programming way of doing that is I++. Either one of those two things will accomplish the same objective. Okay, so I'm going to go with I+. Actually, I'll switch it back because this is what I've been doing in class. But if you understand it, you can feel free to use the other way. I gets I plus 1. Okay, so I'm incrementing I by 1 every time in this loop. And now I can have some commands inside of this loop to do things over and over again. So what I want to have happen over and over again is this pattern here, right? I want to be able to set the pin mode for each pin to an output. So I need my pin mode command. So pin mode, and I need my arguments, LED pin, right? And instead of putting a number, I'm going to put the variable I in that argument. Set it to an output, and there we go. These lines of code right here, these 2 lines of code, my for statement and my pin mode statement here, accomplishes the same thing as these 5 lines of code here. So anytime you find yourself working in a pattern like this, that's generally a sign that you want to be using an array. Okay, so I'm going to comment out these lines. Let's see, we'll do the slash star, and then star slash there. So now those lines of code are commented out. Okay, and we could even write something in here like these lines do the same as our for loop. And why are you doing this double slashes there? You're already commented out. Why would you do that? That's so that when I uncomment it later, those other things still remain as a comment, so that I can kind of show you that this is doing the same thing. All right, so slash star slash. Okay, now that whole block is commented out. The computer's going to now ignore these lines of code. All right, so this will set up my LED pins to be outputs. Okay, so we're almost there now. We've got our LED pins set up. So now we basically need that same for loop again. We're going to have that same structure, except this time we're going to be controlling our loop. And this is the part that I want you to figure out for the homework. Okay, I'm not going to actually write this part out for you. I want you to see if you can figure it out yourself. Because what you're going to need to do is you're going to need to, each time we go through this loop, you want to turn on LED pin I. Right? So every time you step through the loop, you're going to turn on something. You're probably going to want to delay for some amount of time. I'll let you decide what that time is going to be. And then you're going to want to turn off LED pin I. Right, so you basically need 3 little lines there. Now you could add another delay, but what that's going to do is give you a delay before the next one turns on. So the way I've got my code set up over here with these lights blinking back and forth, when one of them turns off, the next one in the pattern is turning on instantly. Okay, so if you do this one for loop, you will have half of the program that I've got running on this other window. Okay, in this other window here, there's actually 2 different for loops. One starts from pin number 1 and turns pin number 1 on, turns pin number 1 off. And I'll stop the simulation so we can talk about it. So it turns pin 1 on, turns it off, and at the same time turns the next one on. Turns it off, at the same time turns the next one on, turns it off, turns this one on, turns it off, turns that one on. Now, if I only had that single for loop, then the program would not do the forward and then back. So what I've actually got going in my program is a second for loop that has a different set of conditions. So I still do int I, but from here on out, it looks a lot different. I'm starting at a different index number. I have a different condition that needs to be true, and I have a different way of incrementing my variable. So I want you to see if you can figure out how to get it to go forward first, and then if you can figure out how to get the how to get the LEDs to move backwards after that. Okay. Now, just to show you that these loops will work the same way, I'm going to go ahead and get rid of this block of code, and I'm just going to go ahead and do digital write. We're going to do LED pin, and we're going to do 0, and we're going to do high. And then we're going to just kind of copy and paste that line of code a bunch of times. Whoops, don't want to do it that way. There, 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 there. And then we'll do LED 0, and then we want to delay. Okay. We'll do a delay of ½ a second. Okay, and then we're going to turn LED 0 low, and then we're going to turn LED 1 on. And we'll add that delay again. And we'll go here. And this time we're turning LED 1 to low. And then we're turning we're turning 2 to high. And then we'll put the delay in there, and then we're going to turn 2 to low, and 1, and then we're going to turn on number 3. So this won't actually get all the lights working, but it should get some of them. Let's see how many mistakes I've made in my code here. So let's start our simulation. Oh, yep, already got one. Forgot my semicolon after the array declaration. There we go. All right, so for some reason 4 gets turned on. The fourth, so pin, oh yeah, 1, 2, and I never turn the fourth one off. So this makes sense according to what I have written. Okay, so I turn on pin 3. Turn off pin 3, turn on pin 5. Okay, then I turn off pin 5, turn on pin 7. Then I turn off pin 7 and I turn on pin 9. Pin 9 never gets turned off, so we can see that lighting up right here and never getting turned off. If I wanted to turn that one off, I would need another command. But all of this, right, I would have to keep this going with a lot of lines of code, and all of that can be done with that simple for loop instead. Okay. Now, as far as the setup goes, I can comment out my setup lines here to show you that this for loop is still going to do, oops, I got to stop my simulation. This for loop will still do the same thing as all these different separate pin mode commands. So let's get that, and I can start my simulation here, and it still works the same way. Right? But these for loops are a much more efficient way of writing code if you have simple patterns of things and you're working with arrays of variables instead of just individual variables. Okay, so set up your array according to the pin numbers that you're going to use on your circuit. I want you to have at least 5 LEDs in your circuit. If you're feeling froggy, you can always go for more. And then you're going to use your for loop in order to set up your pins. Establish your pin modes to output. You're also going to use that same for loop, so we'll get rid of these. We're not going to need those in our program. Okay. Then we're going to use that same for loop in order to control our LEDs. So we're going to start the same way at least once. Okay, and that's should be something you can get. And if you understand that really well, you should be able to perhaps get a second loop, which is going to start in an entirely different index number and have a different condition and a different increment in order to make the LEDs light up backwards. So this loop, we would make the LEDs light up in sequence left to right. Or it could be right to left, depending on how you have it wired. That's really going to depend on the way that you end up wiring your circuit. And then this loop, we should be able to make the LEDs light up in sequence right to left. Okay, so that's your homework assignment for tonight. So we know how to hook up LEDs according to our previous activities. So just remember to look at your diagrams for your traffic light. If you're confused about how to hook up our LEDs, you just need at least 5 LEDs on a breadboard. You probably want to use a larger breadboard. So if I turn off my code here and search for breadboard, whoops, if I can spell breadboard correctly. There we go. And I want to at least probably the small size breadboard. And a helpful tip on the small size breadboard. So let me show you something cool about these small size breadboards and multiple LEDs. All right, so I'm going to bring in this LED here. I'm going to bring in this one here. I'm going to bring in this one here. I'll just bring in a bunch of them. Okay. Now, the negative connection on these LEDs. I have a rail up here on this larger size breadboard where the entire rail is connected. Okay, and maybe I should rotate my breadboard so I can talk about rows and columns correctly. Okay. So remember, the rows in a breadboard in the middle are all connected. I have this dividing gap down the middle, and then the rails on either side. This I want to use this as like a negative rail. So all my negative connections for all my LEDs can come to this one single rail, like so, and then I can have one connection to my ground pin coming off of that rail, and that way I can very, very easily wire all of my LEDs in sequence to the ground pin. Now you will need separate wires and resistors for each LED, so there's no real easier way to do that one. But with the larger breadboard, it is a lot easier to hook the LEDs up to the ground. All right, have fun with that, and see you tomorrow.